Hello, welcome in. We're gonna wait a few moments for more people to join the webinar and then we'll start. Okay, cool. So I think we're gonna go ahead and get started. So welcome to our fifth Role Model Monday webinar. So today's focus is on STEM and high tech, specifically in robotics and semiconductors. So this is our Role Model Monday webinar series. We have a series of webinars throughout the rest of the summer. So you can sort of see here throughout the rest of the month of July, we have four more opportunities to participate in these webinars. And then specifically in the last 2 weeks, rather than it being a recorded panel or a panel where you guys are just listening to us talk, you'll have the opportunity to be on breakout rooms and specifically connect with some of our previous speakers and in the last one, other students here at UT. So yeah, I'm Estella. I a fourth year electrical and computer engineering student here at UT Austin. I use she, her pronouns, and I am from Austin, Texas. We're gonna have Daisy moderating if you want to introduce yourself.
Yes, so my name is Daisy Attaway. I use she, they pronouns. I'm also a WiSTEM crew member, as is Estella, and I'm a rising junior majoring in physics and astronomy, and I'm from Nacogdoches, Texas.
Yes. So all of our Role Model Monday webinars are recorded. You can find them in our YouTube link. So all of the previous ones that were listed are currently uploaded to the YouTube channel. That'll be, you can look it up or it'll be available in chat as well. Yeah, so now I guess we're gonna kick off our panel. So today we have Krisha Bruska today with us. If you want to go ahead and introduce yourself.
Hi, everybody. My name is Krisha Broca. I work at Samsung Austin Semiconductor here in Austin. I'm from a small town in upstate New York, and I majored in chemical engineering at the Rochester Institute of Technology. I have a bachelor's degree. Outside of work, I like to craft and I like to crochet and do a lot of DIY things. So that's what I like to do in my spare time.
Yeah. And then if you'd like to introduce yourself, Elisa.
Yes, hi, can you hear me?
Yes.
Okay, great. My name's Elisa Kepner. I work for a company called See Beyond Data. I've been an engineer for over 30 years now. I have a bachelor's in industrial engineering, a master's in systems engineering, and have focused on algorithm design, which is now called machine learning and artificial intelligence, and have just worked in a lot of different industries.
Yeah.
And I went to Texas A&M. I apologize.
All good. Yeah. I'll ask both of you sort of what drew you to your like undergrad major and how you found yourself in the career that you're currently in. I guess Elisa, if you want to go first.
Sure, and I don't know if you can hear the lawn guys. I apologize. They like to hang out in my front lawn for hours at a time. I really didn't know. I grew up around a lot of engineers, chemical engineers, close to Dow Chemical, and I didn't realize that you could really do anything outside of engineering. So I tried it. I started in mechanical. I'm a terrible reader, but I'm really good at math. And so I sort of bounced around engineering and computer science and landed in industrial engineering and have just loved it. I found the right fit for me in operations research and statistical analysis and never knew that I would love it until I tried it. So that's why I always recommend people give it a try. Try everything. You'll probably find something that you really enjoy doing if you have an interest in STEM at all.
Yeah, yeah.
Mhm.
And then Krisha.
Okay, so I just always liked math and science in school. And so when I was looking for different schooling and everything, I was like, oh, I also like chemistry. So that drew me into chemical engineering. And um, when I was graduating, preparing to graduate, and I was starting to think about a job and everything, I was kind of just applying places in the South because I don't like the cold and the snow. And I saw Samsung Austin Semiconductor pop up and I applied. It sounded interesting. So I kind of just happened to just fall into the semiconductor industry and I've enjoyed it ever since.
Yeah. And then, so my major is electrical and computer engineering. So specifically, my concentration is nanotechnology, and I found that through an interest. Once you're in college, there's a lot of different research panelists that you can attend that are open to all students. So I walked into one my freshman year, and it was about semiconductor technologies, and I thought it was really interesting. So I just started taking those classes. And that's sort of how I currently, as a college undergrad, have found myself interested in like semiconductors. But yeah, I guess how like walk us through like a day in your life, like as a like in your job, I guess, and like what specifically do you do in relation to technology and engineering? Yeah, I guess at least if you want to go first as well.
Sure. So, I mean, after I've been doing it for so long, I've gotten to kind of pick the path that I enjoy the most. So, after you've been working a while, usually, my experience is you become a SME, you become an expert in something, and I'm an expert in solutions architecting. So, normally, because I've designed and implemented so many large analytic forecasting systems, I sort of can see the problems as they're coming up before people can sort of see those. And so I'm normally brought in on teams to map out the way to solve a problem that is sort of unsolvable with a standard large scale ERP system or even large language models, the way to go through and do the training. I can say that, it'll train up to this point, but you're not going to be able to record at this level. And I can kind of band-aid a solution together and then design what that's going to look like end to end. And then I give that normally over to the project manager and to the teams, and I serve more of as an auditor. So I come back and make sure it actually is going to work the way that they think it's going to work. And I love doing that, which means I work on different teams. At any time, I may be on 3 or 4 different teams, and my resume looks ridiculous because it's not like I stay around the entire time. I just sort of design the system and leave. And I've really been able to do that since the early 2000s, when I really got to my start in creating solutions like that, and have tried to sort of stay in that space most of my career.
Would you mind elaborating a little bit more about what you mean when you design a systems? Like, is that coding or for like what sort of application or project that would be?
So because I tend to focus on the data analytics side, or what used to be called big data, and that now you do artificial intelligence and pulling through a lot of different data to come up with a potential solution. I prefer machine learning. I kind of think that's more accurate than a lot of what the AI is in the spaces that I tend to operate in. But some of the first things I worked on is I worked at a company called Manugistics back in early 2000s. And for example, I worked at Porsche. So one of the things we did with Porsche was all of their planning for their manufacturing. So it's all the supply chain, but it was also the planning for it. So their SKU. So then the 81 position numeric and alphanumeric code that tells them what they're going to work on next and how to do planning. Each one of those, some of them had infinite numbers that they could be. So what I was looking at was, here's your manufacturing line, here's all the people that work on your manufacturing line, here's the different SKUs that are coming in and the orders that they have to be completed. And we have at Manugistics a tool called master planning, and then we have another tool called commit, and we had another cool tool called supply, and another one called demand. Not very creative terms, but those had different features, different functions that didn't always plug together. We had 51 different tools. So we had sort of this glue layer that I would say this variable has to feed to this variable, but it doesn't work in this instance. Or you can have up to 12 SKU positions, but there's 81 with Porsche, right? So I would be the one that comes in and says, we have to make this change to this tool. We have to add another tool completely that we have to create ourselves. We have to plug these two together and lay out that solution, that end-to-end solution, and then make sure that we have enough time to and people to build out the way that those are going to work. Normally, I'd have to put the dots real close together, so I'd actually have to design the code that did it, but I do a lot of pseudo coding, and I have for a long time because a lot of systems use different languages. And so usually a more junior person can take that code and then code off of it. And then they learn more about how the systems work and where the limits are in the systems that they're working with. So those were some of the bigger systems I designed. Currently, I just use tools like, Power BI and Power Query and stuff that's related more to more rapid development solutions for right now I work for the Army and I do that inside of the Army for their budget planning processes.
Yeah, sounds good. And then, Krisha, do you want to go over sort of what your job looks like and what you do day to day?
Mhm. So I've had a few different roles at Samsung since I started, but right now I'm a process engineer in the diffusion department. The diffusion department is basically on the floor, on the production floor. Some of the equipment is people like to call them easy bake ovens. They're a little more complicated than that, but they can get to really high temperatures, and we're annealing the wafers or we're depositing a thin film. The process that I'm sort of in charge of and running, we're depositing a thin film and everything. So an average day in my life is I'll come in and, look and see what sort of problems are going on, what maintenance is happening with the tools. And then if there are any issues, working on troubleshooting it and working on problem solving and things. And then also coming up with proactive improvements to the process and everything, to sort of make it more uniform or have less problems, less defects and stuff with the line. So I work with some of the technicians and the equipment engineers quite a bit. Um, and so that's kind of what I do day to day. It changes day to day depending on if we're dealing with a lot of issues and we're fighting fires, or if things are a little bit calmer and we can try to make some more proactive things. So I kind of like that it's very dynamic in the role.
Yeah, so I guess for context for the people attending our panel, even though you might think of semiconductors as being a purely like electrical engineering field, the manufacture of semiconductors is actually very interdisciplinary. So a lot of other fields are involved in the manufacture of semiconductors. Krisha, if you want to
Okay.
maybe talk a bit about more how like your like chemical engineering
Hmm.
major, uh, sorry,
Yeah.
specifically goes into semiconductors.
Yes. Yeah, there's so many different types of engineers and technicians and things. So as a chemical engineer, in my undergrad, I focused a lot on material science and sort of did some undergrad research with that as well. And so that really plays into when you're putting down the film on, we make the wafers that then become the semiconductor chips. And there's a lot of material science that goes into that and chemistry and how all the different films and uh, different things interact with each other. When you anneal it at a high temperature, what happens? So you can go into almost any field in engineering and end up in some sort of semiconductor related field.
Yeah, and then I just wanted to remind all the participants that we have an anonymous Q&A, so you can ask our panelists. And then, so one of the questions would be from our attendees is, what are the most rewarding and most challenging parts of your job? Yeah, at least if you want to take that one first.
All right. Yeah, so I just first of all, I want to say I love hearing about the semiconductor manufacturing. As an industrial engineer myself, I love manufacturing. It's still my favorite passion. And the best industrial engineers that we had to be really good at things like you were just talking about with, chemical engineering and different engineerings, right? So I think that's really cool. It's a really neat, precise manufacturing world. But so I'm sorry. The question was the things I enjoy or the things that I don't
Yeah.
like about my
What
career.
what are the most rewarding parts and the most challenging parts of your career?
At this point, the most rewarding parts are being able to train other people. I have, for probably the last 15 years, always had somebody or multiple people that are junior on my team, and I love watching them create their own solution. I like being able to provide parameters that then they have to come up with a better answer, or they come up with one, and then I can just say, well, but what if this happened? And then oh, okay, well, that's not going to work. So I enjoy that because I feel like that's sort of on the job training with other young engineers, especially that are coming out of computer science and understand maybe some parts of machine learning, but they don't actually understand the manufacturing side of it. And so they create these black boxes. And so it becomes, I like being that bridge. I'd say the most challenging has been I spent about half of my career working in the federal government and I really enjoyed it. And I moved to Austin about 2 years ago. And because things have shifted so much in the workspace up there, I haven't been able to, well, first off, I don't like being this far from when I like being in the office. I like working with teams, and I think it's great that people get to work virtually, but I prefer to be in the office. So I think as the work is shifting, it's harder to make to work as a team if you're doing things virtually, which a lot of computer stuff is, and certainly in the government space, a lot of stuff is sort of coming apart.
Yeah, and then Krisha.
Um, so I'd say the most rewarding part of my job is when you have something that's like a really tough problem, you don't really know what's going on or anything, and we'll get all of the experts or honestly like anyone who like even knows a little bit in a room, and we just like start brainstorming and trying to come up with um, different solutions, looking at data, what tests can we run to get the data that we don't have, and then kind of like getting all that information together and being able to solve a problem. Um, which like it just happened this morning that we've had a problem with some of our equipment that has been going on for a long time, and we finally fixed it. And it was like a big aha moment, like a light bulb went off, and it was just everyone was like, "Oh, we finally got it." So, getting to like work together with, lots of different people on my team, and, we'll get engineers and technicians and, you know, lots of people just trying to like work together to solve a problem. I'd say that's one of the most rewarding parts. Um, one of the most challenging is just how high stress a lot of this is. So, semiconductors are pretty expensive, and it's a very precise process where if I'm putting down a film and it's a few molecules or a few atoms too thick, it's it's all scrap. You can't use it anymore. So there's just a lot of pressure to then make sure that everything is exactly perfect, pretty much.
Yeah, so we've touched a bit about like what you guys' like work sort of looks like, but can you guys talk about a specific project or product that you guys are really proud of that sort of showcases like the STEM skills you had to put to use for our attendees? Yeah.
So I'm assuming that that I'm gonna go. The I'd say that so when I was doing process engineering and a lot of the same thing, I've never had to worry about a molecule. I mean, that's tiny. Like I could, that's a crazy kind of space planning or in manufacturing planning. But I worked through a number of different industries. And back in the late 90s, I created a business process patent that helped figure out what variables you need to use to be able to do better forecasting based on repeatable patterns. And at the height of the war in 2009 to 2012, I was brought in to use that patent to create capacity planning for the major hospitals that wounded warriors were coming back to from theater. So I was able to create pretty simple tool sets with simple algorithms that had the right inputs and right feeds that could predict how busy the hospital was going to be in 3 or 4 months based on arrival patterns and injury patterns. So I could tell them in a month from now, you're going to need to add this many surgeons or this many orthopedists or this many beds. You can't shut down this other facility as much as you want to because you can't take those new patients. And so I was helping them do the planning based off of the things that I had realized doing manufacturing work, 15 years earlier. And I really enjoyed it. I loved doing that. That was my favorite job.
Elisa, would you mind clarifying maybe a little bit more the difference between like process and systems? To me, it sounds like you work mainly in like optimization. So I was wondering if you would clarify for a little bit. Yeah.
It's funny that you say that because, so I worked for a company called MITRE, which is an MIT Research and Engineering, an FFRDC, a federally funded research and development center that was set up by Congress to do systems engineering, right? So it's a nonprofit group that does systems engineering, and they have 12 different definitions of systems engineering, right? So that's why I laugh about it because some people are like, oh, it's just technology, right? But the way my professors always talked to me about it was it's anything where two things touch, right? Any kind of interface that's happening, which could be computers, it could be, I happen to like operations research and process stuff. And I care a lot about people being too busy. Honestly, I don't want them overworked. I want people balanced well, because everybody does better when they don't have too much or too little to do. So I've always really focused on staff optimization and everything else sort of feeds into that. And I've always sort of thought of systems engineering that way. But my husband, who is a mechanical engineer, has 2 degrees in that, does systems engineering, and he says it's a totally different kind of systems engineering. So that's and just like we're talking, there's a million different ways to get to process engineering, right? And you could do it either way that we did it. And I think a lot of engineers do end up in some sort of a process design. And then they kind of come out of it figuring out which touch points they care more about and what they're good at. And then they sort of focus in on those areas.
Yeah, thank you for clarifying that.
Sure.
And Krisha, just to remind you of the question, it was like tell us about a specific project or product that you worked on that can like give us our audience sort of a glimpse into like the STEM that you apply in your job.
Um, so my favorite project that I've ever worked on in my job has been we're building a new fab, a new facility out in Taylor, Texas. So I've gotten to work on that team that's going to be setting up that new fab. So I got to go to Korea for almost 3 months, and I got to go and spend some time at the factories there because they're running that more advanced technology there. So I got to work with a bunch of the engineers there and learn about the process that we will be running in Taylor, and then taking that information and bringing it back here to work on the documentation that we need, all the training and everything for all the other engineers that didn't get to go or the new hires and all this stuff. Um, so it was really cool going and getting to see that and then learning about like some of the most advanced technology out there, and then being able to be partially responsible for bringing it here to Texas.
That sounds really cool. Elisa, do you get a lot of chances to travel with your job, or is it mainly a desk job?
I spent the first 10 years of my career traveling constantly, but they were mostly in the United States. Um, I thought when I moved to the DC area that I would be traveling all the time. I thought it was an international, but no, when you move there, you stay there. And then people, even if you work in the federal government and there are lots of people that travel globally. In the world that I worked in, which was trying to make things better, cheaper, faster, right? Make the government more efficient. That's what I've spent my entire last 20 years working on. Um, that's really mostly focused around that area. But I have two kids. I have an 18 and a 16-year-old boy. And so after I had my kids, I cut my travel way, way back.
And then, Krisha, I think a lot of probably our attendees don't have that much, maybe familiarity or background with what semiconductor fabrication or fab sort of translates to. So I was wondering if you could talk a little bit about like how much of your job is sort of like hands-on or how much of it
Mhm.
is at a desk with like computers.
Yes. So semiconductors are made in a clean room. So out in the world, there's all the dust and debris and everything else that comes around, but that can wreak havoc when you're making semiconductors. So we have to put on a whole gown and suit and everything, and it just prevents any clothing fibers or skin cells or anything from getting into the air. And we have a bunch of filters and everything. And so that's where all the actual equipment and everything happens, is in this very clean environment. Um, as a process engineer, I don't get to go into the fab nearly as often. Um, Maybe every like month or so, if there's something that's like really big happening, I'll go and like specifically look at, a tool or equipment or something that's going on. But right now, most of my job is done at a desk.
And then I guess so related to that, if you're doing mainly like data analysis or sort of working with like crunching numbers, if you run into problems, how do you try to like troubleshoot them? Elisa, if you want to go first.
So pretty much every day is troubleshooting day to day, right? It is that seems to be the end all be all problem. So no matter because as an industrial engineer working in a variety of different industries, I've never been the expert in the industry. And I think one of the things I enjoyed about working in healthcare when I worked in healthcare is it's so clearly not industrial engineering. So I always had usually a nurse that understood the process as well of the place that and they were my partner. Like we were attached at the hip through everything that we did because you always need somebody to help you understand data. So today I work with budget offices and I understand numbers, but I don't understand exactly, right? So I don't know if it says, $250 million dollars that it's supposed to be $223 million dollars. And I have a spreadsheet full of data. So I have to have people that are experts that are helping me identify that data. On the flip side, with, if you only have the experts in the field looking at it, they don't understand how the data is plugged in between the larger back-end systems and when it gets imported into the data lake or whatever you're pulling it from, and then the transformation of the data and how it's being connected. So there's multiple steps that an engineer usually is the one who figures that out and codes it. But one change in the process and how it's recorded can just destroy all the data downstream, and you won't even know you're looking at bad data, right? So it's always very important, even after you get a system designed and you are predicting, the most amazing thing, and everybody gets excited and they keep hit and go every day, that the what you're looking at is right. And so you need people that are both the technical side and then you need the specialist side to be able to make sure that your data is accurate every day in what I do.
And then Krisha, do you want me to repeat the question or
It was about problem solving, right?
yeah,
Yeah.
or like how do you troubleshoot in your day to day?
So, yeah, it's a big part of my job. And so it's a lot of looking at data from the sensors and the tools. So what temperature are things running at? Is there a shift in any sort of voltage or anything? And then in combination with some of the data from the actual wafers themselves. So what is the thickness of the film? How many defects are there on the wafer? Is the composition off? So kind of using those kind of things. So if say you see that um, the composition is off. Okay, then it could be because of this part is failing. So then if that part is failing, you'll go and you'll see that like, oh, this sensor is reading out of spec. So that's kind of the route that we take with troubleshooting, is that like one thing kind of leads to the next and you check like one data after another until you get to the root cause of the problem.
And then we had one of our attendees ask if you could recommend any sort of activities or things to get a glimpse of semiconductors to those who are still in high school.
Um, so I don't know anything specifically for high school, but I know like some of like Girl Scouts will have like little conferences, webinars, kind of like what we're doing here that are even longer and a little bit more technical into the semiconductors. Um, so maybe be on the lookout for things like that or um, trying to think.
Yeah, and
There's
then
also just lots of like free learnings on like YouTube and stuff. You just search like how are semiconductors made and you can find so many videos of what it's like in the clean room and how the process goes about. So,
yeah, and
yeah.
then I can speak a bit about that because right now I'm still in college and I'm doing electrical engineering. In high school, I had a lot of interest, I guess, in physics and math. So I definitely encourage you to take math classes, take challenging physics courses, but also there's a lot of virtual coursework you can take that's related to electrical engineering. I think if you're in robotics, that's also like one avenue to sort of like dip into electrical engineering. Maybe it's not specifically semiconductors. But if you look up something called MRC or Material Science Research like Confederation, they have like a lot of different online websites or like online resources, like virtual webinars that are very like helpful in terms of maybe getting a bit more exposure to the technical aspect of semiconductors. And I think what's best to keep in mind is that semiconductors is so inherently multidisciplinary that's like there's a lot of avenues to get into semiconductors. Like I'm electrical engineering, Krisha's chemical engineering, and there's also you can work on it through mechanical engineering and also through like computer engineering. Like there's a lot of different aspects of engineering that go into semiconductors. I think if you're in high school and you're wanting to try to go into that, know that semiconductors is like very niche, but also very like large and interdisciplinary. So there's a lot of different ways to get into it. And once you are in college, it's easier to find those avenues. I think in high school, you just want to build a strong foundation for college. I don't know if you want to add to that a bit more, Krisha.
Yeah. So I think what you said was really great. There's also, yeah, like lots of different areas within semiconductor itself. So, like I work in the manufacturing for the wafers, but there's also packaging, which is how do we get the wafer made into like the actual chip to put into the phone, computer, car, whatever. Um, there's design as well. Like there's so many different like areas within semiconductor too that, you know, you can I think anyone can find something for them in semiconductors, depending on what you are interested in.
Nice. Yeah, and then we had a question. I was asking what skills or experiences helped you the most when you were starting out in your career? Uh, yeah, I guess Lisa, when you were starting out, like specifically like right after college. Yeah.
So I started, I actually did a co-op. So I started doing engineering, literally the same sorts of engineering stuff I do now when I was like 21. And I worked every other semester at Train Air Conditioning. And I was going to ask, because both of you guys are in semiconductor, my experience a long time ago was that you had to be the top of your class. So if people want to go into semiconductors, I think you really do have to be like star students. I don't know. I was not a star student in undergrad. By my graduate work, I was pretty good. But in my my co-op job, they gave me a book that I literally have on my bookshelf over there still. It was from Witness. It was a discrete event modeling simulation package. And they said, we're going to build a new plant. We need you to design it. Go build a model. And I had no idea what that was. And I sat down and started to build agent-based models and loved it. Just took to it like a duck to water, loved it. And so when I went back to college, I had a totally different view on what industrial engineering meant. I understood statistics in a way that I didn't understand before. And so that work helped me go back and forth. And I stayed in, you know, simulation for years and years and built out a lot of my understanding of having these sort of God's eye view looking down on processes. So I was lucky enough to have wandered into the only one of two places I could get a job because my grades weren't all that great. And when I got there, they gave me an opportunity to learn something that in the end has, carried me. So I don't know that you can plan, I guess is my point. I think a lot of times you just get yourself prepared to get up to the precipice of the next step, and you will get an opportunity, and then you'll have a chance to try something else, and you'll learn something else in that space. I wish there was a more straight line of, how to figure that out.
So would you say like the co-op experience was something you found really helpful when you were starting out your career?
Extremely. I did two things. I had the co-op experience, and then I did an aptitude, not an interest, but a real aptitude test because I kept switching my majors and I couldn't figure out what I wanted to do. And it told me what I was going to be good at, and it helped me, especially as a woman, it helped me really build up my belief in myself. I was like, oh, I really am good at this. Like, I'm better than 97% of the population at this one thing, right? So that sort of helped me target, and then it helped me feel confident in presenting my ideas, knowing that I was probably better at it than I had originally thought. But with the co-oping, I mean, I don't think I would have had a clue what I was doing if I hadn't done co-oping, even if I had made it all the way through college, because those courses did not relate to me at all of what happens on the floor in manufacturing. And I liked both of them, right? But I needed to say, why am I taking this course? Why am I taking a course in optics, which I thought I was going to die in, right? Because as industrial engineering, you have to take civil engineering, mechanical engineering, electrical engineering. Thank God, no chemical engineering because I'm terrible at chemistry. But you have to take all these different engineerings, and that makes it sort of confusing if you've never seen manufacturing before. So I think co-oping is a really good idea. I think it's probably really good for any engineering, honestly.
Yeah. And then for like our high schoolers who are attending the webinar, a co-op is basically like a longer internship. So I think internships are generally in the summer, whereas a co-op would be like instead of the fall semester going to class, you would be working with a company, and then like in the spring semester you would go back to class, and you'd still be a full-time student like during your co-op semester. Yes.
Yes, and I did mine for like 3 years, every other semester. So the problem with co-op, the biggest problem, is that you lose your class. Right. So after the first year, all the people I was going to school with, all my study partners, everybody went ahead. It took me an extra year and a half to graduate because of my co-op. But in the end, I rolled right into engineering. I mean, I didn't even look for a job. I had multiple offers. And so it was a different, transition from college to full-time jobs.
Yeah, yeah. And then, Krisha, do you want to talk about any experiences or skills you found really helpful, like finding a job?
So I want to reiterate everything Alyssa just said about co-ops because I also did a couple of co-ops. Um, very sounds like it's a similar thing, where it took me 5 years to get my degree. It was still only 8 semesters of classes, but um, at where I went to school in RIT, co-ops were required, so I didn't like fall behind or anything, and they had like specific like you're in a co-op this semester, this other semester. Um, so that was kind of helpful, but yeah, co-ops were so helpful. Um, they were totally unrelated to what I'm doing now, but it kind of helped work on the skills of like how to like actually work in a team environment in a job and also kind of like what I liked and what I didn't like about those jobs. So then I can like pick and choose of what I want to look for in a job. That was also pretty helpful. Um, but the biggest advice that I have for when you're just starting out at any job, whether it's a co-op, full-time, whatever, is do not be afraid to ask questions because you're coming in, you're not going to know what the process is there or how to use, the specific system or website wherever you are. And the only way you're going to learn is if someone teaches you or you ask a question. And a lot of times you're working with someone who, is training you and everything, and they mean really well, but they may not explain everything well. So if you have any questions or you're just curious, just really don't be afraid to ask questions. There are no stupid questions.
Yeah, and then you sort of answered it already, but like on that vein, one of the questions our attendees asked was if you could go back in time and give one piece of advice to your younger self, what would it be? I guess, Krisha, would it still be the ask questions?
Yeah.
Yeah, yeah. And what about you?
I love that. I think that's fantastic because it's so true. Along those same lines, you are forgiven for any stupid question for a good 2 or 3 years, right? Don't wait until you get older and then you don't know anything. Like ask questions. I'd say very much along those same lines is when because it's if it was my younger self after I had first gotten my job at Train Air Conditioning, what I did, I got so proud of myself and I wrote all these things down and I was like, here's what you need to change, right? Because I'm sure I had the right answer. I was brave enough to go and say these things to my boss. And my boss was kind enough to say, thank you so much for putting this together. Let's walk through these. We did this last year. It doesn't work. We did this before. Maybe this is a good idea. So we got through it and it made me realize that I wasn't the only person that had ever had a great idea, right? But that people had had other ideas, but I still could come up with things and I was still safe, right? So the more, especially as women in STEM, because I've done enough stuff with WeSTEM to see the thing that concerns me the most about the women is not how intelligent they are, it's how reserved they are. Even the few guys that show up always are more, they step out more. And although that wasn't my issue, maybe I needed to be a little quieter for a lot of the girls, I would say the most important thing is, believe in yourself. Ask questions, make comments, be part of the team, step up, right? You can't mess up all that much when you're first getting started.
And then, because you guys have both already like gone through school and are in full time, whereas Daisy and I are both like still students. I was wondering, like in regards to technical work, both like in school or in your career, like if you had a really big like challenge with like engineering technical work, sort of how did you overcome that? Because I think like in school, I think you can go to office hours or like the TA, but I think for technical work in like your career, how is that sort of different? Or is it like more, do you feel like you struggled more technically in school or like currently in your job? It's just, yeah. I guess Krisha, if you want to go first. Yeah.
So, yeah, like I come across questions all the time of things I don't know. Um, I think everyone still does because there's just so much to know at any company, any job or anything. So one of the things that's really helped me is networking and making sure you have like a friend or at least an acquaintance that you can like, I am in a department and be like, hey, I have a question about this, can you help me or direct me to the right person? And like everyone is always, yeah, sure, here's the information, or oh, this person on my team would be able to help you the best. So if you have those connections, then you can always find the information that you need. So.
And then Elisa.
I think it's funny because I think when you're first coming out of school, what you're really strong in is technical, right? And what you're not really strong in is understanding the environment or the company or the nuances, right? That's, I feel like you may be looking to solve a problem that isn't that big of a problem to solve. Now, at my point in my career, I run across stuff I don't know all the time because it's been a long time since I went to college, right? And I think one of the beautiful things about artificial intelligence is what you can learn from it. The amount of time I spend talking to artificial intelligence every day is shocking, and I use it for absolutely everything. I have been able to figure things out that I didn't even know I didn't know I didn't have it right, or I haven't had somebody that understood that tiny little nuance to I'm like, But what happens if I do this with this variable in this order of code and it's like, nope, it's not working that way, right? This tool doesn't work the same as this other tool. And so even the most technical issues, I can get answers. Um, Usually quicker than anybody in my company because as a subject matter expert, I'm supposed to know all that, right? So what I find with young people that are coming in right out of college is often they have a lot of technical knowledge and either they're hanging on to it and they don't know how to apply it, or they're sure that it's the right answer. And so they're just starting with that, even though they don't know that maybe it doesn't fit in right there. So it's having the ability to not only learn the right answer, but figure out how to insert yourself where you're being heard, but you're not running over everybody is, I think, a really strong, a good skill to have. If you're going to UT in STEM, like you are, you're going to have no problem technically. You're going to be so far advanced to anybody else in the room. I would not be as concerned about that as, maybe in college it's harder, but you're going to get out to the rest of the world and realize they're not that technically sharp anymore.
But yeah, and then sort of in that vein, I think within engineering, like within any field, you can specialize a lot. So how important would you say having a master's degree or going beyond a bachelor's? Like how important is that within your area? And Krisha, I know, I think you can correct me if I'm wrong, you just have a bachelor's degree. Yeah, like do you mainly work with other people who only have bachelor's degrees, or do you work with people who have more degrees, and sort of like how does that fit into like your sort of job ecosystem and the work you do?
So, yes, most of the people that I work with, engineer-wise, have a bachelor's degree. I'd say about 80 to 85% of people just have a bachelor's degree. Um, and then maybe like 10% has a master's. And then there are a few people that have PhDs as well, and they work with me. So I think it depends on what you want to be doing. If you want to focus more on research, then having a graduate degree is more important. But at least at Samsung, the having a graduate degree isn't as important. Um, like it kind of it doesn't really factor into like how you get promoted. Like I know executives that have just a bachelor's, and I know some that have like multiple, like a master's and an MBA and stuff. So it really is just how you apply your like information and stuff. I think having a master's degree definitely helps, but it's not really required, in my line of work at least.
Yeah, and then Lisa.
So that's one of the things about being in Texas is, and really actually in a lot of places, is a master's is not required. I did not have a master's when I left here. When I got to, nation or global level stuff, I was sort of forced into it. I was working at SAIC at the time, and my boss was like, "We'll give you this management position over the East or the West Coast, but not without a master's. You have to go get a master's." So I had to go back but I wanted to do engineering, so I did systems engineering at UVA, but it was a hybrid with Darden with the business school. So what I do now and spend a lot of time thinking about is much more business side. So and if you're going to stay in Texas and you're going to certainly do even really awesome manufacturing, um, more complex manufacturing, I don't know that a master's in an engineering field is necessarily going to help unless you're going to be doing research. Like if you really have some cool ideas about how you like something related, masters are great places. You'll have, professors that really think differently at the master's level, and they love students that want to do masters. It's just a different dynamic. I love my professors for my masters, and I started my PhD at UVA before we moved back, and I loved my professors. I mean, but I hated school, and I didn't like teachers when I was in it when I was an undergrad and even younger. So it took me a while to warm up to the idea of school, even though I have degrees. But I'm a big believer in don't do more than you really need. I think a PhD will potentially limit you in job offers. You're too educated. You're too far. They assume you're too far down this pathway that you're not going to want to do some of these other tasks, and that may not be true. So, just make sure that if you're going for at least a PhD and potentially even a master's, that it's something that you really need to do.
Yeah, I think that's at least like as a current college student, like for undergrad, that's definitely something I was sort of struggling with. Like, oh, do I want to go work or do I want to plan to do more school? And I think if you're maybe early on in college or still in high school, I think you don't have to have your heart set on doing grad school so early on. I think definitely going into my freshman year, I was like, oh, I'm going to do PhD and I'm going to be like so cool and do more education. But I think being in like college is just like getting a better idea of sort of what avenues, like what other options there are in my like career path. Because I think there's a lot of room for change. I think it sounds like both of you had like a lot of sort of maybe a bit of uncertainty starting and then ended up where you guys are. But yeah, so we're going to wrap up our webinar. Thank you both for spending your time with us. If you are interested in, or for our attendees, if you're interested in any of our other webinars, I put the link in. I will put the link in for how you can sign up for the rest of our webinars. And then if you had any other specific questions, we have a virtual Padlet, which is just a website where you like a questions form. So if maybe you asked a question and it wasn't able to be answered, feel free to go in and we'll be checking that. Me and Daisy will be checking that and reaching out if you had specific questions. Yes, I put the same link in twice. I'm sorry. But yeah, I'll put that link in and then yeah, yeah, Daisy put in the YouTube channel. Sorry about that. Sorry, give me a second to get this link in. Yes. Okay, that's our Padlet link. But yes, thank you so much for spending your time with us. Yeah, and that concludes our webinar for today. Thank you.
Thank you. Bye.
Bye.